When you think of a spaceship taking off from a planet and flying into space, you would usually imagine engines and large exhaust nozzles at the back of the ship flaring or turned down towards the ground for thrust vectoring, therefore generating a huge amount of thrust in order to launch the massive vessel into the air and then propel it into space. However, in the setting of Dune, we don't see any of that. Dune ships, whether in the books or in the movies, whether in the 1984 version or the newer, more recent films, seem to just float or hover and fly away. There hasn't been a single ship that we have seen that appears to have any engines or thrusters at all. So why is that, and how do they fly? Here in this video, we will showcase and explore how the spaceships in this setting, Dune, how they take off and fly from a planet into space. Let's get to it. To begin with, the hardest part of a spaceship's journey is not actually flying through space, through vacuum, but actually getting off from the planet in the first place. A vessel weighing thousands or even millions of tons must first overcome the pull of gravity, and doing this with conventional rockets requires tremendous amounts of energy and fuel. The problem becomes even worse when the fuel itself adds weight, which means that the engines need more fuel simply to lift the additional fuel. A powerful launch can also have devastating effects on the environment. The enormous heat, pressure, and exhaust produced by a spacecraft that big can scorch the ground, destroying vegetation and throwing huge amounts of material into the atmosphere. Avatar's interstellar vehicles provide an extreme example of this idea, as seen when they landed on Pandora in the second movie, and how their engines devastated many square miles of pristine forests just so that the spacecraft can slow down and have a safe touchdown on the ground on the moon. Thus, the energy requirements will become more enormous as the ships get larger, and eventually the launch system itself becomes one of the biggest challenges of the entire spacecraft. Science fiction therefore solves this problem in many different ways, depending on how advanced the setting's technology is. In Star Wars, repulsor lifts can first raise a starship from the ground and then allow it to hover before its main engines carry it into space. Star Trek uses similar technologies like artificial gravity and gravity nullifiers for the same hover, and then switch to impulse drives to fly away. In Warhammer 40k, the enormous void ships are usually built in space, but when they come to the ground, they rely on their colossal plasma drives to slowly climb away from a planet before reaching the safety of space. Halo takes a more conventional approach, with its massive warships generally not designed for atmospheric operations and thus requiring powerful external thrust couplings like rocket boosters when they must leave a planet. The common idea behind all these technologies is that science fiction has to find some way around the rocket equation, but then again, when they are in space, we see the engine nozzles or nacelles that propel the spaceship in the direction it needs to go. So, now coming back to Dune, why are there no such things here? The spaceships here in this setting, at least in the movies here, seem to only float around like UFOs, or UAPs as they are known now, which are kinda ominous in a way. See, in Dune, space travel is usually portrayed as something that is almost completely separated from the conventional idea of spaceship flying across the stars that we see in other settings. Here they travel between star systems through artificially generated wormholes inside massive ships called Heighliners. These vessels are more like gigantic transportation hubs, capable of allowing entire fleets of smaller spacecrafts to travel through them from one place to another. The key technology here is the Holtzman engine, which allows the ship to fold space rather than physically crossing the enormous distance between two stars. From the perspective of those aboard, a journey that would normally take months or years can happen instantaneously. The immense size of the Highliner is also important because the Guild has to make room for the large spaceships that would sometimes go through the Highliners. Smaller ships can enter the Highliner and effectively use it as a bridge between the distant worlds, thus making the Guild's vessels the backbone of civilization and commerce across the known universe. However, the real marvel of Dune space travel is not simply the ability to fold space, but the ability to do it safely. The Holtzman technology can create the means for instantaneous travel, But without proper navigation, a ship could emerge in the wrong place or collide with a planet, a star or an asteroid, or just drift away in the void. This is where the Spacing Guild Navigators become essential. These navigators are mutants. Through generations of exposure to enormous quantities of melange, the spice melange, the most critical component in the entire setting, the navigators develop powerful prescient abilities, which allows them to perceive possible futures and determine a safe path through folded space. This is why the guild becomes so powerful here. It controls the only reliable means of moving people and goods between distant worlds instantaneously. But this doesn't really answer the question of how spaceships take off, doesn't it? The Heighliners and the Navigators describe how space travel from one system to another is possible, but not really how the spaceships leave the planet and get to the Heightliner in the first place. So the answer is that DUNE's seemingly engineless spacecraft make use of a phenomena known as the Holtzman Effect, and this physics phenomena here allows for a piece of technology known as suspensors to be created. Although rockets do still exist here in the DUNE universe, they are largely an old and inefficient form of propulsion, especially for enormous spacecraft. They are in a way almost obsolete. Heretics of DUNE in the book makes clear that conventional rocket propulsion was still used when ships were not relying on the Holtzman drives, but larger vessels could use Holtzman suspensors to overcome much of the problem of defeating a planet's gravity. Suspensors are essentially gravity nullification devices that use a low energy phase of a Holtzman field to reduce or counteract the effective weight of an object. This technology is already common throughout the DUNE society. It allows glow globes to float, supporting enormous structures, providing artificial gravity aboard spacecraft, and can even be worn by people to reduce their effective weight. Baron Harkonnen. A gigantic spacecraft equipped with powerful suspensors could therefore lift itself from the ground and hover without requiring enormous rocket engines constantly blasting exhaust downwards. This explains why DUNE ships can appear to simply rise from the surface and float away despite having no obvious engines. However, suspensors don't really completely replace propulsion. Their main purpose is to counteract gravity and provide lift rather than magically propel a vessel across space at high speed. Once a ship has escaped the immediate problem of planetary gravity, some other unknown form of propulsion is used for acceleration and maneuvering. This is maybe the Holtzman drive. See, Holtzman technologies provide the revolutionary first step and even the second step, but to go from one star system to another, well, that is up to the Heighliners, with the Holtzman effect allowing the ships to fold space, and thus making interstellar travel instant. This creates a useful distinction in DUNE. Suspensors solve the problem of lifting a massive vessel into space, and maybe through some related technology, the Holtzman drive, they can propel it to escape velocities to reach orbit. The Heighliners then fold space and allow cross-system jumps. Because these technologies are so advanced and deeply integrated into DUNE civilization, the spacecrafts shown in the films can appear almost completely silent and engineless, simply floating away from their landing platforms. What looks like a missing propulsion system is therefore actually one of the setting's most important technologies that is operating largely out of sight. However, the exact power source of these is never clearly explained in DUNE, and this is one of those areas where the setting deliberately leaves the underlying engineering kind of vague. What we do know is that suspensors are powered applications of the Holtzman effect, using a low energy phase of a Holtzman field to counteract gravity. The generator therefore needs some external source of energy, but Frank Herbert never establishes a single universal fuel or a reactor that powers every machine in the Imperium. DUNE instead shows mixtures of technologies. Glow globes, for example, are able to draw energy from their surroundings, while still suits use the wearer's own movements to operate their pumps. Larger installations and spacecraft could reasonably be assumed to use powerful generators, with nuclear or atomic energy being the most likely source given how important atomics and nuclear technology still remain in the setting. Smaller machines could use batteries, fuel cells, or other localized power systems. The important point is that the suspensor itself is not generating unlimited energy or simply creating gravity cancellation for free. The Holtzman field provides the physical effect, while a power source should supply the energy required to maintain that field, with the amount of energy increasing according to the object's mass and the degree of gravitational effect being counted. So, how fast can DUNE spacecrafts travel through space without a Guild Heightliner? Well, the answer depends heavily on which era and source material being considered. The older form of conventional space travel, before folding space, was apparently capable of speeds vastly beyond that of the speed of light, and it was described as outracing photons, although it was much slower than Holtzman space folding, obviously. The expanded DUNE works provides clear examples even though they are not really canon. For example, in the Butlerian Jihad, the Unified Armada gathers at Seleucus Secundus before traveling to Old Earth, a distance of roughly 130 light-years away, and Xavier Harkonnen states that the fleet required more than a month to make the journey, at its maximum sustainable speed. If we use the approximate distance of 130.8 light-years and treat 1 month as about 30 days, this kind of works out to roughly 1600 times the speed of light. These numbers should be treated as rough estimates rather than precise canonical speed ratings, since they are not really from Frank Herbert's mind or works. Anyway, the books don't really provide a formal acceleration or a maximum speed specification, but it is clear that even without Highliners, the FTL speeds of DUNE ships are still pretty insane. See if this is true, and that conventional FTL speeds of DUNE spacecraft potentially being hundreds or even more than 1,000 times light speed, that would make them extremely fast by most science fiction standards. Even so, they were still considered slow, since the Guild's Highliners were still vastly more useful because space folding effectively removed the journey time altogether, allowing them to move between distant star systems almost instantaneously. And so there you go. That is how spaceships in DUNE take off from a planet, fly into space, travel between systems, and even go full conventional FTL mode, beast mode, and still be considered slow. Now with that, we end this video. Do hit the like button for support, and also click the bell button for regular updates and new video uploads. Also subscribe to be a part of Legion Nerdbug, and till the next time, take care, boys.